Tell us why Pulsar uses conventional drilling over fracking. What are the benefits?
I think for this question, it's good to provide a brief explanation on the difference really between drilling and fracking, or hydraulic fracturing, which is the more common technical name for it. All wells for hydrocarbons or industrial gases, such as helium, require a conventional style of drilling with similar styles of rigs. The difference really lies in with the method of how a well is completed after the drilling process is completed and why a particular method is selected. For conventional wells, such as at the Topaz project, once drilling has completed, the well is able to be produced with minimal additional works. Conversely, some wells are unable to be produced without a hydraulic fracturing or fracking operation. For fracking operation, after the well has been drilled, specialty equipment has to be mobilized to the well, which then pumps a mixture of water, sand, and a few benign chemicals into the wellbore. That procedure then applies a hydrostatic pressure to the target reservoir interval until it induces a fracture into the reservoir rock, which extends laterally from the wellbore into the reservoir formation. And the sand in the mixture flows into the fracture and remains in place to hold the fracture open so that it does not collapse once the high pressure subsides. And is basically a hydraulic stimulation operation in 3 sentences. But as for the benefits, there are a number of benefits to a conventional completion versus a completion requiring fracking. However, I will focus on 2 that I think are most important to Pulsar and the Topaz project. First benefit is in the significantly lower cost of a conventional completion. Hydraulic fracturing can often double or even triple the capital cost of bringing a well on production. Topaz does not require hydraulic stimulation, as the helium and other gases are able to flow to the surface under natural conditions, and this significantly reduces that initial capital requirement for a well at Topaz. A second benefit for the Topaz project is the reduced social risk. In recent years, some vocal members of the public have developed a negative view of fracking. As hydraulic fracturing is not a requirement at the Topaz project, the perception of environmental risks related to fracking is essentially non-existent. There are other benefits as well, however, cost savings and social license are 2 key benefits in my mind.
What impact, if any, will Pulsar's operation have on the local environment?
Pulsar's operations, particularly at the Topaz project in Minnesota, have been planned and executed with a focus on minimizing environmental impact. Having recognized the potential environmental challenges associated with the helium extraction project in northern Minnesota, the operations team has implemented a robust and comprehensive approach to assessing possible impacts to the local environment. The initial 2 activities on the ground in Minnesota were 1, to sanction a regulatory rules review in order to understand the local regulatory environment, and 2, to sanction a flora, fauna, and wetlands review of the property where activities would occur. The activities that Pulsar was proposing were first of their kind in Minnesota, and these comprehensive reviews enabled Pulsar to operate from day 1 under the umbrella of existing regulations. And by working through existing federal, state, and county permitting frameworks, Pulsar has been able to minimize potential impact to the local environment. Additionally, Pulsar regularly engages with the local community to address concerns around environmental impacts and on what a helium operation might look like once it is in full production. Pulsar has been proactive and open with the activities taking place at the worksite. We have hosted hundreds of visitors to the site, with the common response from stakeholders when they see the worksite is, "This is it." The message we want to convey is that helium exploration and ultimately production is a low disturbance activity. Work sites are relatively small, especially when considered next to the large-scale mining operations common to the Minnesota Iron Range. And once a well is depleted, it is abandoned with industry best practice. All service equipment is removed, the site is regraded to original topography, and then finally reseeded with native flora, allowing the site to return to native forest conditions. Although the presence of helium activities will be around for a number of years, any minor disturbance to the local environment is ultimately both minimal and temporary.
What consumables are required for producing helium at Topaz, and how does this differ to other resource extraction projects?
Well, a number of consumables are required for helium operations at the Topaz project. These can be divided into consumables during the drilling phases and then consumables for the production and processing operations phase. During drilling, the primary consumables are tubular goods such as conductor pipe, surface casing installed to protect groundwater resources in the region, and intermediate casing for well control. Other consumables required during the drilling phase is the cement used to secure the casing into the wellbore. During gas production, separation, and processing, a variety of consumables are required to address the many activities taking place. Gas production will require compression, which requires regular maintenance for safe and efficient operation. Consumables might include lubricants, hydraulic fluids, gaskets, seals, and O-rings. Separation and processing requires a number of different processes to address the unique gas stream at Topaz. Cryogenic liquefaction coolants to separate the gases, then to liquefy CO2, molecular sieves for removing nitrogen, and membrane filters to remove minor components in the gas stream. The consumables required for helium production and processing are orders of magnitude less than other resource extraction processes, especially when compared to the mining industry where excavation, crushing, and beneficiation are required to get to a saleable raw material. Excavation, for example, requires explosive, blasting caps, and drill bits. Crushing requires grinding media such as steel balls and rods. And transporting the raw materials also requires liners for crushers and mills, as well as conveyor belts and bearings for loading materials onto rail cars and maritime vessels. Just the profound scale difference between helium extraction versus mining extraction operations necessitates significantly more and larger scale consumables for the mining processes.